Hey guys, this is Chidanand from Infotech NG, and I welcome you to this short tutorial. Hopefully I'll keep it short on Kubernetes. Kubernetes using Let's Encrypt, which is nothing but a freely available signing authority for certificates, and using NGROK, exposing my local Minikube cluster services to the outside world. What I plan to achieve is detailed out in this diagram. So I have a local Minikube cluster. Minikube is nothing but a single node cluster that runs on your local Windows or Linux desktops. Now this has to be exposed to the outside world. Now there are a couple of things in it. First and foremost, I would have a bunch of pods and a bunch of services which are powered by these pods, and these services would be exposed or would be abstracted within my cluster using something called as a Kubernetes Ingress Controller. And specifically, I plan to use NGINX Ingress Controllers. There are a lot of Ingress Controllers out in the market, and I don't want to go into details of what is this Ingress Controllers. These are all covered in my previous tutorials. You can refer to it. So first and foremost, I will have a few pods running. I will have a few services up and running. I will connect them together using this NGINX Ingress Controller. Now, having said this, now these services are only available within my local IP or within my Minikube. Now, I would want to sign some certificates using any available external service. Now, LetsEncrypt is one very popular encrypting service, which is getting very popular in the recent times. It's a free of cost service that allows you or which gives you a certificate so that anybody who wants to set up TLS or SSL certificates can connect their applications to LetsEncrypt and ensure that they get a self-signed certificate or a certificate that is signed by LetsEncrypt based upon who has registered the domain and stuff like that. Now, the way LetsEncrypt would work is that they need to authenticate if at all you are the true owner of a particular domain for which you're seeking a certificate. Now, since my cluster is running locally, I don't have any way of exposing this to the outside world. That is where I use a very wonderful utility called NGROK. Now this will tunnel my local services onto a US server and somehow ensure that my local service is available to the outside world at a very specific NATed address. Now this would keep on changing based upon how long I run NGROK. Now many people consider NGROK as a security threat and stuff like that, but I'm a trainer. I use NGROK extensively because there are a lot of times when I want to expose my local services or local traffic to the outside world. I wouldn't definitely recommend you to run this anywhere else other than your development or testing environments. All right, a little bit of detail about how does this Let's Encrypt work. Now, this is Let's Encrypt. You can go through all this documentation that is available, but essentially whenever anyone seeks a particular certificate for a specific domain, Let's Encrypt will try to validate that or challenge that using some HTTP tasks saying that put out some particular specific stuff out in this location and stuff like that. Now in order to do that in our scenario, since my local Kubernetes cluster is not available to the outside world, I would use NGROK to make my services available to the outside world. I'm going to trick Let's Encrypt in believing that whatever dynamic domain that I'm going to get from my NGROK URL, I own that particular URL. So this way, I'll somehow ensure that Let's Encrypt can reach into my particular cluster. So that's about Let's Encrypt. All right, now for those of you who don't know how does Kubernetes certification manager or how is the certification validation done on Kubernetes, it has been simplified a lot in the latest Kubernetes versions. So there's a simple certification managers that you can use. The one I'm going to use is the JetStack certification manager. Now For those of you who don't know how certifications work and all that, it's pretty easy to understand from this, where you would have a certification manager available on your cluster who is responsible for talking to all certificate authorities and internally grabbing their certificates and storing something relating to those particular certificates within your cluster. Now, most of your certificates would be generated and an equivalent Kubernetes secret. That is where the keys of the certificates are stored. Now, this is what is stored back in the cluster. So this is a very, very easy setup, and you will realize that once I start my demo. All right then. Hopefully I'm pretty clear. I've made it clear as to what exactly I'm going to run. And as I said before, I will not be running too much into the YML files and what I'm setting up, because these you can always refer to my previous tutorials. Okay, to summarize my local Kubernetes cluster, I've got few pods and some services. I'm going to install NGINX Ingress Controller, ensure that these services are available internally, and then expose those services using NGROK to the outside world. Then install a certification manager here. Somehow ensure that the certification manager can talk to LetsEncrypt, or LetsEncrypt can talk to the certification manager running on my box. Set up some HTTP challenges and ensure that my cluster is able to communicate to LetsEncrypt and get the secrets pertaining to the signatures or the certificates that are generated by LetsEncrypt and put them back here. Now this will ensure that anyone can use or get into my cluster. Let me get started with my demo. All right. Now I already have a Minikube cluster that is up and running. Let me just show you. Yeah, Minikube. Let me show you all the versions that I'm using. I'm running on a Windows 10. I'm using Minikube version. All right, that is the Minikube version, kubectl version. The client is 1.18. The server is also 1.18. And what else? Okay, kubectl cluster -info. I'll show you my running cluster. All right, so I have a plain Minikube cluster, a single node cluster that I've started. There's absolutely nothing running on it. Now all the source files that I will be referencing will be uploaded into this repository. I'll give this repository the link to this repository in my video. All right, now first and foremost, what I want to do is I want to run few pods. Okay, so let me look at few of those pods that I'm going to run. So this is a simple pod. The pod name is hello.yml. This is the name of my pod once it comes up. This is the label. I'm just echoing something. I'm using a echo server and I'm echoing something. Hello, the text is hello in this case. I'm creating a service specific to this particular pod. All right, so I'm going to create two of these services. One is called hello, the other one is called welcome. Both of them have just a change is only the text that is going to be output on this. So let me just get started with that. Kubectl create -f hello.yml. That's the first pod, and next one would be my welcome pod. Now if you notice, there's a pod created, there's a service created as well. So let me just check that. Kubectl get pods. Okay, kubectl get pods. There are two pods up and running. Kubectl get svc. These are the services. There are two services, hello service and welcome service, and these as of now have just a cluster IP because I haven't asked them to be exposed as anything else other than a cluster IP. Now, for those of you who know about the networking in Kubernetes, cluster IP is nothing but a particular IP which is available only within the cluster. I'm not really worried about all these IP addresses because I'm going to anyway use my NGINX controller and ensure that these would be exposed to the outside world. Now, first thing is I'm going to use, since I'm using Minikube, I want to ensure that I will enable the add-ons for my Minikube. So Ingress is one of the add-ons. So by default, it would not be on. I need to turn it on. So Minikube add-ons list. Right, you'll see a lot of these add-ons. So Ingress is out here, which is disabled. So in case if it's disabled, turn it on. So Minikube add-ons enable Ingress. Now this will ensure that the Minikube support for Ingress is turned on. For those of you who know about Minikube, you understand the complexities involved in actually running this demo on a Minikube versus running this on a real cluster. Alright, so that is the reason why I would want to enable this add-on, which is nothing but my Ingress. Now my application, or rather my cluster, is ready to support NGINX Ingress or any Ingress controller for that matter. So I have an Ingress controller here. This is a version which I forgot which version that I was referring to, but you will find that whatever version of Ingress, this is the complete YML for running my NGINX Ingress controller. So all that I got to do is just say kubectl create -f NGINX. This is as good as me installing an NGINX controller on my particular cluster. All these are very nicely configured in, so that if you see whatever my NGINX would need in order to perform its NGINX Ingress controller functions are all here. It's going to create some namespaces, it's going to create some config map, it's going to create some service account, cluster role bindings, and all this stuff. So let me just check if at all there is any pod running here. kubectl get po in the namespace ingress -NGINX. Alright, so now this particular controller is what is responsible for this particular pod is one of those things which is responsible for ensuring that NGINX runs properly. It will take some time for this guy to come up. Oops, alright, so he's still creating the pod. kubectl get rather describe po. The name of the PO is this fellow, and in the namespace, what was the namespace? Ingress NGINX. Okay, it's successfully trying to run this. Okay, everything looks good. I don't see any problem with this. It's just that it's taking some time because my machine is pretty slow. Alright, it's up. It is ready, running perfectly fine. Now there are a lot of other things involved with this Ingress controllers, but I don't want to go into details of all that. So this would ensure that my Ingress controller is up and running. Now once I have my NGINX controller up and running, I would want to tell a few configurations to the Ingress controller. So I have two services which are running within my hello. So one is called the hello service, other one is called the welcome service. Now I want to link them together and let my NGINX Ingress controller know where are these, or what are the paths to which these two are mapped. And that part of it is what I do in my greeting ingress.yml. Now this is a configuration file that I need to create. So I'm going to create a new ingress. Ingress is a kind. The name of my ingress is greeting ingress, and I'm going to tell this fellow that whenever there is a request coming into hello for my particular node, or in this case my Minikube cluster, redirect that to my hello service. If there's anything coming to welcome, redirect that to welcome service. Now welcome service, hello service are already defined. So what happens is, in no time, all my rewrites for my URL will be taken care of by my Ingress controller. So let me try to create that. kubectl create -f, what was it, greetings ingress.yml. Alright, so kubectl get ingress. Alright, get svc. Alright, so I don't see any, no, we don't need any services created for this. Yes, this ingress is sufficient enough. Okay, kubectl describe ingress greeting -ingress. Alright, So this has got the backend part. There are two things. Hello is linked to hello service. That's what I want. Welcome to my welcome service. Now this is pretty good enough. So if I say Minikube IP, I will get this IP address 192.168.99 and 101. So if I open a browser and hit this along with hello, I'll be able to hit my hello service. If I do a welcome service, as simple as that. However, my services are available only within my cluster. Now I would want a way to expose this to the outside world. That is where I use a wonderful utility called NGROK. Now this is what I will use in order to tunnel my local traffic to the outside world. I pretty much get a NATed IP for any of my service that I want to run. Now, though NGROK is a very popular and useful utility, as I said, my requirement is just that I have my local cluster. I don't have any way of exposing this to the outside world. In case you already have a domain where you're launching your Kubernetes cluster, you can make all the required DNS changes to affect that. But this is just for me to try out. So there's a simple exe that you got to download, and then I'll show you how to run this NGROK. Which can expose whatever type of port that you want to the outside world. Now I already have that downloaded here. I'll come to this a bit later. But before that, I want to install this certificate manager. I want to ensure that I don't have a certificate manager running. So let me install my certificate manager and ensure that I create an environment or a cluster issuer for my certificates. Now let me do that. The command for that is let me create a namespace called cert manager. Again, this is not required, but this is a better way of doing that. So let me create a namespace called cert manager, and then use this apply f, and I'm going to use this 0.12.0. that's the version. In case if you want some other version, you can always ensure that you use that particular version. So this is the command for installing my cert manager. kubectl apply f validate false. Okay. So in no time, whatever is required for installing my certificate manager gets installed, and if the versions are correct, it would have no problems in installing that. All right, now this is just that it has begun. So let me just check if at all the pods. I would need some of the pods of this certification manager to be up and running. That is how I will ensure that the pods with the proper certification manager would come up without any issues. So you see that there are 3 pods. One is a webhook, one is CA authority injector, a couple of things out there. So they're still waiting for, or rather waiting for them to come up. All right, let me pause the video for a minute and then come back once these are up and available. It took a few minutes for my certificate manager pods to come up. So if I look at this, so yeah, I have all my pods up and running. Now this is as simple as installing a certificate manager. Now having installed a certificate manager, now what I want to do is I just want to ensure that I create a kind of a certificate cluster issuer or cluster issuer for my certificate. So I'm going to create something called as a cluster issuer, and the metadata for that is the name for this cluster issuer is LetsEncrypt staging, and I'm going to create this within my namespace cert manager. And this is the standard specification for the cluster issuer, referring to the LetsEncrypt staging server. Now, the server is acme-staging-v02 as it is, and this is an email ID. Whatever certificate that will be gotten from LetsEncrypt would be put in the secret LetsEncrypt staging certificate or a secret. All right, and then the solver's HTTP class Ingress. So I'm going to just create a cluster issuer, which is nothing but a kind of a agent on my local Kubernetes, which will talk to various certificate issuing authorities. All right, so let me do that. So kubectl create -f greeting ingress. No, not this, not this, not this. Yeah, staging certificate dot YMO. Okay, so kubectl get cluster issuer. All right, so we have this cluster issuer which is created. So kubectl describe cluster issuer and this guy. All right, so you would see if there's any error with the certificate registration or if the URL is not correct for just the cluster issuer. So I'm just requested a cluster issuer who should be talking to the LetsEncrypt server. Now comes the tricky part. Whatever services and ingress controllers that I've set up, this is all within my local cluster. I need to have a way of exposing this to the outside world. Though I've set up a cluster issuer, I've really not talked to the LetsEncrypt server for creating some certificates. Now, before I do that, I have to have a way of LetsEncrypt server talking to us. So they would talk to us using a particular IP address or a particular DNS name. So that is where I would want to use NGROK to expose my local cluster. As of now, I have just one service. I want to expose not one, a bunch of services, but all these are at a particular IP address and a port. So I want to expose that to the outside world using NGROK. So I already downloaded NGROK, and let me show you how to run NGROK. So first of all, Minikube IP. This is my particular IP address. Now on this IP address at port 80 is what I have where my services are defined. So I need to expose this out. So I open up another command prompt. I have an NGROK that I have downloaded. If I do a dir, NGROK is out here. So I'm going to run NGROK with exposing the IP address. So 192.168.99.101. So this would be like this. So NGROK, I'm going to run this executable file. I'm going to expose HTTP port, or rather HTTP traffic. And what is that I want to expose is 192.168.99.101:80. Now this is where all my services, local services, and my NGINX is running. NGINX Ingress Controller is running. All right, so let me open that up. All right, now as long as I have this up and running, this is a simple kind of a shell thing on my Windows command prompt. So as long as I have this particular address is what is my natted DNS name for my service. So if I copy this and open up a new tab and type this in with the hello, I should be able to hit my service. Now this, as long as I have it running, even if you try this out with this particular URL, you should be able to hit this. Now I successfully managed to expose my local services that is running on a particular IP address which is within my Minikube cluster to the outside world using this URL. And if you see here, this is not secure because I have only HTTP running. So I need to ask LetsEncrypt to get me a certificate to this particular URL. So let me modify that part of it. Since this NGROK URL is dynamic, anytime I run it, I get a different NGROK URL. But that's good enough for me because I'm just going to try out something. So let me go back and modify my demand for a certificate specifying the URL. So if I go back to my source code, there's a file which has to be modified. Greeting NGROK Ingress. So this is very similar to the previous ingress that I've defined. The only changes are, as below. Okay, I'm adding some annotations. Annotations are just for documenting stuff. If you see here spec TLS, this is what I'm adding extra here. So this time I'm going to specify the host, and this is where I would need to specify the URL of my particular NGROK, which is dynamic. Every time you run this, you get a different IP, and the secret name is echo TLS. So whatever certificates would get generated would in turn be stored in this particular CLS. Secret. And the other things are all the same. So this is what will ensure that a certificate manager will hit my, or rather will request Let's Encrypt for getting a certificate for this particular host. Now, since we are available, or my service is available on this IP address, when Let's Encrypt server tries to hit my service, it will be able to ping my service any HTTP challenge. It will be accepted, and everything goes well. I should have a certificate up and running. So let me open up that particular thing, and then I would need to modify the host address here based upon whatever I got for my particular. Let me just double check that. Okay, so this is my URL. Now this would keep changing every time I run this. So in case you're going to try this out, you would have to modify this based upon whatever DNS name that you get from NGROK. Okay, we don't want this HTTP part of it, just this, and dot is good. All right, so I'm updating this because this ingress is already there. Earlier when we created this ingress, we didn't add this part of it. Now that I'm going to update this TLS specifying this, so I'm going to use kubectl apply. Apply will ensure that only the changes are done. -f okay, creating NGROK ingress.yml. Now this will ensure that the changes that I asked for would be requested. Now hopefully there would be some when the request is sent out to Let's Encrypt, they would probe this particular URL asking for special things. So you would possibly see a few hits on this particular NGROK UI, or rather NGROK traffic. This is where NGROK shows you all the traffic that it has received. In the meanwhile, let's go ahead and check if at all. Oops, 9D, is this what I put in? 9D, yep, that's what I put in. So let me just look at kubectl get certificate. Okay, echo TLS. So describe kubectl describe certificate. Echo TLS. Okay, requested. It is waiting for the certificate request to get completed. In the meanwhile, let me see if there is some traffic here. Nope. Requested, waiting. So this at times may take some time for this to happen. So let me pause the video for a minute and come back once the certificates are generated. Please bear in mind that the NGROK service that I'm using, it's pretty much reliable most of the times, but there are times when there would be too much of a traffic on NGROK, and since I'm a free user, the connections would get aborted at times. So that was what was happening to me. My NGROK connection had reset and I was not able to reach the address from the outside world using the NGROK DNS name or URL. So I had to restart that. After that, it took a couple of minutes for my certificate to get created. So let me just check that. kubectl get certificate. Right, the certificate is ready. It is called echo TLS. So let me just describe that. kubectl describe certificate echo TLS. Now that's the certificate. It looks ready. This is the secret name where the certificate is kind of stored. So let me also check what is there in that secret. kubectl get secret. All right, this is the secret that is there. So kubectl describe secret. Go TLS. So there is some certificate that is stored with CRT and key, and this all looks good. Let me also look at what happened to my NGROK. So if you see this, there would be a lot of traffic that would have been hit on my NGROK. This is just because remember the HTTP challenge that I had put in. So let's encrypt will probe this particular URL and try to store some or rather try to check if at all the challenge has been accepted and the particular set of keys or whatever was the HTTP challenge was kind of set out. Now this gives you a feeling that everything is right with your cluster. Let me now try to open up Incognito window and see the HTTPS URL and see if I'm able to hit my service. Alright, I'm able to hit my service. You would see that this doesn't show anymore like an unprotected thing. Shows that it's a valid certificate. Probably for the certificate, since I have Kaspersky installed, you would find, yep, you find validation by Kaspersky, but nonetheless, this is a valid certificate. And please mind that we installed the certificate or requested for a staging environment certificate, but this is not a production certificate. There is small changes that has to be done in our environment, or when we request for the certificate, the URL for the Acme URL for LetsEncrypt is different. But if you modify that, you would get a perfectly running certificate for your production box almost free of cost. We quickly set up a Minikube cluster. We were able to put some pods on it, expose some services for powered by these pods, and install NGINX Ingress Controller on our Minikube cluster. Able to see if it works locally. Also exposed the service to the outside world using NGROK, the free version of NGROK. Now this being exposed to the outside world, I was able to talk to a LetsEncrypt server, request a certificate using a cluster issuer. The certificate, though it was for staging environment, the steps are pretty much same for production environment. And if at all you are really authorized to use the domain, in this case, in my case, it was just a sample domain that I was trying. But in case if it's a realistic domain with the proper DNS settings, you can get a ready to use production certificate that can be used to sign your applications running on your Kubernetes cluster. Thanks a lot guys for watching, and as usual I'll put up all the source code and the steps in the detailed section of my video in case you have any trouble in running it, or if you hit upon any issues, kindly leave a comment and I will try to address it as and when I can. Thanks for watching, and you guys have a great day.